Within BioMedBridges, 10 biomedical sciences research infrastructures, BMSRIs, have joined forces to construct the data and service bridges needed to connect them. Disciplines brought together range from genomics via biological and medical imaging, structural biology, mouse disease models, clinical trials, highly contagious agents, to chemical biology. Together they serve a large part of the vast biological and medical research community, estimated to be at least 2 million scientists in Europe across more than 1,000 institutions.
It's quite a challenging project because for the first time it joined together, or aimed to join together, the different infrastructures for life sciences around Europe. And traditionally they haven't always worked very closely together, because life science at the molecular level is quite distinct from life science at the cellular level and life science at the whole organism level. And this project was attempting to bring the data from all these different infrastructures together in some way, so that it would be exchangeable, interoperable and interpretable.
For example, project partners have harmonised image annotation of biological images to enable co-analysis of mouse and human tissue samples for biomarker discovery.
Venimis Connect is an open source software that has been developed within BioMedBridges. It's a software that helps the integration and search of biological samples stored by biobanks. We realized that something important for the biobanks it was that they didn't change the data model. So we developed these tools based on that requirement, but also something that we wanted to do is to give something back to the biobank. So we developed the tools in such a way that they could reuse these tools, for visualizing their own information, for analyzing their own information, and for integrating that information into all the biobanks.
A web-based shape-matching tool allows shape-based searching of vast structural biology data resources and can ultimately support the integration of data from the molecular level to that on the tissue and whole organism level.
In the BBMRI community, the data on patients in biobanks cannot be openly accessible because of privacy concerns. So we have been trying to work on the processes and information systems, enabling users to go to the biosamples database, discover potentially interesting information for them, and then jump to the BBMRI infrastructure and obtain more information on the samples they are interested in.
Most of the data produced in life science is openly accessible. In some cases, however, like in human health research, data needs to be access controlled for ethical, legal or societal reasons.
We have developed tool REMS to support the decision-making process for open but access-controlled data. REMS streamlines the process between a researcher needing access to that data service provider holding the data, and an authority like a biobank, which can grant access to data. Once the parties identify themselves electronically, then the access rights can be stored into a central database held in REMS. Thus, each European data service provider does not have to keep track which researcher has which access right. REMS holds that information can provide it upon request.
A diabetes-specific ontology enables users to integrate data resources for mouse disease models and human data, while taking into account different stages in the development of diabetes in human patients over time.
You have multiple groups of people referring to one thing differently or different things with the same term, and ontology tries to normalize that. This is because you need everything to be interoperable so that they can integrate together and data start to make sense again. We call this tool ontology. So we have this ontology lookup service to provide you with the means to look for the specific ontologies that might fit what you're looking for.
So going forward, we had a bit of a learning curve in the project because different scientific communities to some degree speak different language and do different languages and do things in slightly different ways. So what we have now is a solid basis from which we can keep developing the data integration and interoperability into the future.
What BioMedBridges tries to do is to ensure that the interface between these different communities within the life sciences gets better. so that we can exchange our data, because it's very clear that over the next 10, 20 years, the real novel discoveries in life sciences will occur at the interfaces between the molecular and the cellular and the organismal, and that we need to join all of this data up. Gradually, and this isn't just in Europe, this will be globally, that we will develop much better tools and ontologies and identifiers that will allow us to seamlessly exchange and interpret data.